Temperature. It is the degree of how cold or hot the body is. It can also be defined as the measure of an average value of the kinetic energy of a molecule in a random motion. The temperature rises if the molecules have more kinetic energy.
In this temperature scale, you will know where the water boils, water freezes, and where it is absolute zero in either Kelvin, Fahrenheit, or Celsius.
The zeroth law of thermodynamics stated that if two thermodynamic systems are both in thermal equilibrium with the third, then it means that they are in thermal equilibrium with each other. Accordingly, thermal equilibrium between systems is a transitive relation. The effects of heat. There are two effects of heat, which are the change in phase and the change in temperature. In change in temperature, there are the thermal expansion, heat capacity, and specific heat, while in change in phase, there is the latent heat.
So this will be the formulas that will be used in getting the delta L or in getting the coefficient of linear expansion. In terms of volume expansion, these are the formulas that will be used in either getting the change in volume or the coefficient of volume expansion.
The question is, what will be the volume of 80 milliliters ethyl alcohol at 10 degrees Celsius when it is heated to 60 degrees Celsius? With beta from the coefficient of volume expansion table of ethyl alcohol, which is 1100 times 10 to the negative 6 per Celsius degree. The formula that we will use is delta V, which is equal to volume, beta, and delta T. Volume is 80 milliliters. Beta is 1100 times 10 to the negative 6 per Celsius degree from the table. And delta T is 60 degrees Celsius minus 10 degrees Celsius, which is 50 degrees Celsius. Degrees Celsius. And the answer is 0.44 or 4.4 milliliters.
So the next sample is, the question is, a 1 meter steel rod is heated from 25 degrees Celsius to 50 degrees Celsius. By how much will it expand and what will its final length be? So since we're looking for the final length, the formula in order to get it is this. LF is equals to length times 1 plus alpha delta T. So this is the formula that we will use. First is L. We have to determine first which is L, and that is the 1 meter times 1 plus. So this alpha is given in the table already, so it is from the coefficient of linear expansion table, which is 11 times 10 to negative 6 per Celsius degree. So that is the coefficient of linear expansion of steel rod. Next is multiply it by the delta T, which is 25 degrees Celsius, because we got it from that formula of final temp minus initial temp, which we will get 25 degrees Celsius since final temperature is 50 degrees Celsius.
So here's an example. For example, is opening a tight jar. When you can't open a jar, what do you usually do? Well, there are a lot of tricks for this. Or maybe just like tapping the lid of the jar against the counter to break the seal. Or maybe you use one of those grippy rubbery things, but that's a technical term. But one way you can open a tight jar is by running the lid under a hot tap. This causes the lid to expand. But wouldn't an expanding lid make it tighter? To explain this scenario, imagine heating up a donut-shaped piece of metal. Does the donut hole get larger or smaller? People tend to think smaller because they imagine the expanding donut filling the hole. But if the complete shape expands, the hole also gets larger. So if you heat up a jar lid, the gaps between the lid and the glass threads gets larger, making it easier and way faster to open. Extreme heat is not just dangerous for people and planes. It also makes train travel hazardous by causing railroad tracks to bend. When temperature rise, steel tracks will expand, meaning they get longer. An 1,800 foot length of rail will expand almost 1 foot with an 80-degree change in temperature. For example, heat-related expansion places a lot of stress on the ties, ballast, and rail anchors that keep the track fixed to the ground. Eventually, the tracks will buckle under the force. These are called sun kinks. It makes the tracks look like spaghetti. So here's another example. The gas gauge in a car. People are much more likely to run out of gas in the summer than winter. Why do you think it's that? Well, here's the explanation. The gas in your car expands, just like anything else, and changes the reading on your fuel gauge. In the summer, the gas takes up more space in the tank, and so when it reads empty, there's a significantly less fuel left in the tank than in winter. Maybe you get an extra 35 miles after it hits empty in the winter. But that won't be the case in the heat of summer. So here's another example. For example, is a thermometer. It also works by expansion. The liquid in a thermometer, which used to be a mercury, but is now usually an alcohol of some kind, expands as it gets hotter. And the marks on the glass are calibrated to tell you the temperature based on how much the liquid's expanded.